Hold on tight to this planet because this video will blow your mind. Hello Internet, welcome to my astronomy final. Long story short, I have to talk about all of these topics. Let's get this thing started. Our first topic today is ancient astronomy, mainly the geocentric and heliocentric theory. The geocentric theory was a theory when Earth was in the middle of our solar system. Ancient astronomers believed in this because people believed that God would choose them to be first. However, as you know, that theory was debunked by Copernicus and Galileo with the heliocentric theory, which shows that the sun is in the center of our solar system. Our next topic is stars and constellations, which can be presented in an HR diagram. The luminosity represents how bright a star is, and it also relates to the size of a planet. The temperature is obviously how hot a star is, which relates to the color of the star. The higher the luminosity, the bigger the size, and the hotter the temperature, the more blue it gets. There are also circumpolar constellations, which are constellations that are always visible in the northern hemisphere. They're called these. I do not know how to pronounce them, and I am not going to. Next is the solar system formation. One theory in particular is the condensation theory. The condensation theory is when our solar system evolved from a contracting nebula. To explain this, the nebula contracts under its own gravity, and as it spins, it starts to flatten to a disk. And as it continues to flatten and spin, it becomes denser and hotter, especially in the center, and then that forms a star. There are also Kepler's 3 laws of planetary motion. One of them is planetary motions are ellipses, with the sun at one focus. The second one is that planets farther from the sun move slower, which is aphelion, and planets closer to the sun move faster, which is perihelion. The third one is that planets farther from the sun have larger orbits. Next are the terrestrial and Jovian planets. The terrestrial are the 4 inner planets of our solar system, including Mercury, Venus, Earth, and Mars. They have a low density, and they are small, rocky, close to the sun, and they rotate slowly. They have weak magnetic fields, with few moons and no rings. The Jovian planets are in our outer solar system, and they are Jupiter, Saturn, Uranus, and Neptune. They're large and gaseous, far from the sun, they rotate quickly, they have strong magnetic fields, and they have many moons and have rings. Next is the TRAPPIST-1 solar system. There are 7 planets in TRAPPIST-1. Those 7 planets are all Earth-sized and terrestrial. Also, the star in TRAPPIST-1 is a cool dwarf star in the constellation Aquarius, and its planet's orbits are very close to it. There are 3 habitable planets in TRAPPIST-1, those named E, F, and G. But what is considered a habitable planet? Well, it needs to be Earth-sized, because if it's too small, there's not enough gravity to hold onto a life-sustaining atmosphere. But if it's too big, it holds onto too much of the light gases, which is hydrogen and helium, and it turns into a giant. Also, there are all exoplanets, which are planets that orbit stars outside of the solar system. Next is Moon and Mercury, mainly its impact cratering. Impact cratering is a crater on a planet or moon caused by the impact of a meteorite or other object. The impact cratering pictures are here. Next is our good old planet Earth. Its surface features are rocky since it's a terrestrial planet. Its atmosphere consists of the troposphere, stratosphere, mesosphere, and thermosphere. The Earth is suffering from the greenhouse effect, which is sunlight that is not reflected but is absorbed by Earth's atmosphere, warming it. The sunlight that is reflected is absorbed by the atmosphere, which causes further heating. Next is Venus, which is the 2nd planet of our solar system. Its surface is relatively smooth with 2 continent-like features, which are Istar Terra and Aphrodite Terra. It has mountains, a few craters, volcanoes, and large lava flows. Its atmosphere is very dense, mostly carbon dioxide. The upper atmosphere has high winds, and the lower atmosphere is calm. Just like Earth, Venus is suffering from the greenhouse effect also. However, Venus is the victim of the runaway greenhouse effect, which means it keeps getting hotter and hotter as infrared radiation gets absorbed. So remember kids, if you don't take care of our Earth, it might turn out like Venus. Next is Mars, the 4th planet of our solar system. Many landers landed in Mars, including these. There are 6 rovers that landed in Mars, which are Mars 2, Mars 3, Sojourner, Spirit, Opportunity, and Curiosity. One past mission was rovers, Spirit and Opportunity. They have far greater mobility than the Pathfinder rover that landed in 1997. The main goal of these 2 rovers were to find evidence of liquid water that may have been present in the planet's past. One future mission is from the SpaceX founder Elon Musk, saying that traveling to Mars is within reach, with the possibility of having 1 million people living on Mars within 100 years. For many years, Mars was a planet B, or a secondary option if Earth was destroyed. So there are many ideas on how to make Mars terraformable, or making it habitable. To make it habitable for us, it would need to be similar to Earth. For example, you need to raise the temperature, have water stability, and thicken the atmosphere. However, as of now, it's not possible to terraform Mars into making it habitable. Next is Jupiter, our 5th planet of the solar system. Jupiter has 63 small moons. Its 4 largest moons are the Galilean moons, which are Io, Europa, Ganymede, and Callisto. They are similar to terrestrial planets. Jupiter protects our solar system due to its huge size, which makes it have a gravity 2.4 times greater than Earth. This is important because it slings comets around, which prevents it from hitting us. Jupiter's magnetosphere is surrounded by belts of charged particles, which is 30 million kilometers across, which is 20,000 times larger than Earth's, which can extend beyond Saturn's orbit. The planet is covered in thick red, brown, yellow, and white clouds. The clouds make the planet look like it has stripes. One of Jupiter's most famous features is the gray-red spot. Its atmosphere is hydrogen, helium, small amounts of methane, with ammonia and water vapor. Next is Saturn, the 6th planet of our solar system. Saturn has 62 moons, 6 medium moons being Mimas, Enceladus, Tethys, Dior, Rhea, and Iapetus. I bet I pronounced those wrong. And 1 large moon called Titan, which is as large as Ganymede. The rings of Saturn are large and complex. Its ring particles vary in size, which are fractions of a millimeter to meters. Its composition is water ice. The reason for the ring, which is the Roche limit, which is the closest distance that the moon could survive in Saturn's orbit. Its surface features are 3 cloud layers which are thicker than Jupiter, and we can only see the top layer of Saturn. Its atmosphere is hydrogen, methane, and small amounts of helium and ammonia. Next is Uranus and Neptune, the 7th and 8th planets of our solar system. Uranus and Neptune are actually very similar. Their atmosphere is hydrogen, helium, ammonia, and methane. Their shade of blue-green, which they got from the gas in their cloudy atmosphere. They both have a weird and off-centered magnetic field which gives them strength. And obviously, they are both Jovian planets, which means they have rings. Next is the Voyager 1 and 2 missions to Jovian planets. The primary mission of the 2 was to explore Jupiter and Saturn. After making a string of discoveries there, such as active volcanoes on Jupiter's moon Io, and intricacies of Saturn's rings, the mission was extended. Voyager 2 went on to explore Uranus and Neptune, and is still the only spacecraft to have visited those outer planets. Next are asteroids, comets, and meteoroids. There are 3 types of asteroids, C-type, S-type, and M-type. C-type being carbon, S-type being silicate, and M-type being metallic. Comets are made of rock, dust, water ice, and frozen carbon dioxide, carbon monoxide, methane, and ammonia. As such, they are properly described as dirty snowballs. Meteoroids contain nickel and iron. All 3 have similarities. First, they're believed to be remnants of the materials that created the sun, and all 3 are too small to become a planet. The asteroid belt is a circular disk that occupies millions of asteroids. It's between Mars and Jupiter, which separates the terrestrial planets from the Jovian planets. And last but not least, evidence of life on other planets. Extraterrestrial life has been hypothesized to exist in the solar system and throughout the universe. One major evidence of life are signs of water in planets, just like Earth. Liquid water is widely thought to have existed on Mars in the past. There is evidence that Mars had a warmer and wetter past, dried up riverbeds, polar ice caps, volcanoes, and minerals that form in the presence of water. Ceres, the dwarf planet in the asteroid belt, has a thin water vapor atmosphere. The presence of water in Ceres has led to the speculation that life may be possible there. Enceladus, a moon of Saturn, has some of the conditions for life. It has geothermal activity, water vapor, and possible under-ice oceans that were heated by tidal effects. And that is it. I hope you guys enjoyed the video. If you're my teacher, you should give me that 100. If you or anybody else, I hope you learned something new, and I hope you press that subscribe button, because it took this amount of work to make this video. Why did I choose a video for this project?